Okay. Hi, Julia. We are going to work on our project most of the class, but we have a few things to discuss, and we're including you in this discussion. We're on day OneNote, chapter 5. You have these, and we're looking at the check your understanding here on the front, just as a warm-up to get back into the swing of stat here this afternoon. According to the Book of Oz, the probability that a randomly selected U.S. adult usually eats breakfast 0.61. Explain what probability 0.61 means in this setting. So, we talked about yesterday what 0.5 meant when we flipped a coin. So it's very similar thinking. So, Allie, would you take a stab at that?
Okay. If you were to randomly select all of the U.S. adults, 61% of them would eat breakfast in the morning.
Yeah, that's right. So it's what law is coming out to play that we learned yesterday?
Law of large numbers.
Right, the law of large numbers, that's right. So the law of large numbers is going to explain that. And it means that 0.61, that means if I took a poll of this school, would I get 0.61 people eating breakfast? Probably not, but because I didn't want it to be, it probably would be. But let's say that the law of large numbers kicked right in, and we would not see 0.61 eating. But if we did every school in the United States, it would be very close, if not 1.61.
There's a whole other law that says that's the outcome you're looking for.
Yeah, we need to name that one.
It's like
Whatever
Murphy's Law.
outcome you're looking for, it ain't happening.
Murphy's
It ain't happening. That's the rule. All right, part B. Why doesn't this probability say if 100 U.S. adults are chosen at random, exactly 61 of them usually eat breakfast?
Because of the law of large
No,
numbers.
right. And 100 isn't large enough. All right.
What is large enough?
Yeah, exactly.
Yeah, I know. It's one of those.
Like 100 are normally considered like a large enough amount.
Yeah.
Depends on how big your
But-
thing is, your sample, you're getting it from.
So you have to have like billions or like
Yeah,
millions?
Yeah, I know. It's a good
Or-
question, Allie. I don't have the answer.
Well, probably not billions.
I think
No.
when you look at the scenario, it might help. That's all I can say. All right, probability is a measure of how likely an outcome is to occur. Match one of the probabilities that follow with each statement. So they listed 0, 0.01, 0.3, 0.6, 0.99, and 1. So, which one, Bailey, goes with this outcome is impossible? 0. Elena, this outcome is certain. It will occur on every trial. 1, exactly. And so we're down to you. Caleb, this outcome is
0.5.
very unlikely.
Oh, 0.
Very unlikely, but will occur once in a while in a long sequence of trials.
0.01.
Yes, so it's just a tiny bit above 0, but it will occur very, very infrequently. All right, and Brandon, this outcome will occur more often than not.
0.6.
Yeah, that's what they said.
And why is 0.01 not on there?
Y is 0.01. That is very close to 0, right? 0 means impossible. It will never happen. So 0.01 means it'll happen, but not very much. All right.
I would actually probably use them in
We're going to turn over and look at the back quickly. Just, we don't even have to read that. Let me show you what's going on in that chart. The only thing I wanted to emphasize about that chart is I started yesterday talking about simulation of chance processes by either rolling a dice, flipping a coin, random table, or your calculator's random function. So, I think tonight's homework, I haven't even looked at it yet. I've done it, but I haven't looked at it. Does that make sense? I did it a long time ago, and I haven't looked at it recently. But I think you're going to have to create simulations from scenarios. So, look at the homework, which is, you don't have that paper yet. Jot down on this paper the homework. So I'm not going to give you a day 2 one yet. I should have, but I don't have it. Actually, I do, but we don't have anything else to write on it except the homework. So it is missing in action. Well, we can get it from our chart with all the days on it. Could someone find that chart in their
It's
possession?
15, 17, 19, 23, 25.
All right.
So 15.
Anyone want to hear that again?
So that would be page
It's just
295.
numbers 15 through 25 minus 21.
Okay, odd.
Odd minus 21.
15, 17, 19.
All right, and in order to do those, you're going to have to create simulations. So they'll give you a scenario. So let's just look at one example. And they want you to do the 4-step process, which is
State, plan,
State,
do, conclude.
do, forget.
State,
State,
do,
plan,
conclude.
do, conclude. If you forgot it, it's in the column there on the chart in the back. So state, plan, do, conclude. It's always the plan I forget. Or one of them I forget. I don't know which one I forget. But I always end up with 3 of the 4. So do better than I did. Notice the first scenario, we're going to look at the vertical column. It says, how likely is it that? So read that, Elena. It's talking about a fair lottery.
How likely is it that a fair lottery were to result in 5 females and 3
I think we talked about this one. And so they said, so how could you test for that? And I kind of went over it yesterday. And so they actually wrote it out in step by step. So they stated the problem, they planned the solution, they used a deck of cards. I think we talked about using random digits or something. And you have your choice. And then, so see how they put in red cards for male pilots and black cards for female, and they shuffled and dealt 8 and counted how many females there were. So, and then they made the conclusion. So I think all 3 of these we've seen earlier in the chapter or last chapter. So when you read them, you won't be surprised, but that's what a simulation looks like in all of its glory. All right, so let's talk about that last check your understanding, and then I think I'm done blabbing for today. So Brandon, would you read check your understanding number 1 on the back, where it says refer.
Refer to the golden ticket parking lottery example. And the following month, school assembly. The 2 lucky winners were once again members of the AP Statistics class.
All right, wait a second. I don't think you saw that one. Did we talk about that one? I don't see it on the chart. I think it was in the book. Before, let me interrupt you, Brandon, and then I'll come back to you. What they did is they had a parking spot for the students, and they had 95 cars coming from the students. And every month they had or week or something, what was it? Month. They drew 2 of the 95 out, or they used the random table or whatever, and those 2 people got to park at the prime spots right by the door. I mean, it doesn't get much better than that. So when they were a little suspicious because there were 95 students involved in this, and there are 28 kids are in the stat class, and both the golden ticket winners came from the stat class. So everyone was kind of mad. They thought this has been totally rigged. So they wanted to do a simulation to find out if it was rigged or not. So what they decided to do is, and Brandon's is a slight variation from that. So let me describe what they did to do the simulation, and then we'll go back to his scenario to see if you can tell me what should be changed. So what they did is they took the 95 students and thought of them 01, 02, 03 down to 95. And they went into a random table, they took a line, and they went down the list. So suppose they got 5158. That was the first 4 digits on their row. That meant number 51 got the spot and number 58. And only 0 through 28 are in the stat class. So those 2, that simulation was a no. There was no kids from stat. So then they went the next 4 digits in the random table, and maybe they were 21, 7-6. So the 2-1 was in the stat class, but the 7-6 was. But that still was a no, because they want to find how often do both of them come from the stat class. So you understand the simulation? Going down the table and looking for two people, four numbers, looking for both of them to be between 0-1 and 2-8. So when they did that, guess how many times before it hit yes?
70.
How many?
70.
And it was 10. So 10. And then they did it again. They just kept going down the table, and guess when it happened again? The 6th time. So it turns out that this is very possible to get two people from the same class to win the spots out of 95. So there's 28 out of 95 in the class. So that's a type of simulation. All right, listen to Brandon's version of it and tell me how you could vary the simulation. Sorry, Brandon, try it again.
Okay, so this assembly, the two lucky winners were once again members of the AP Statistics class. This raised suspicions about how the lottery was being conducted. How would you modify the simulation in the example to estimate the probability of this happening just by chance?
So basically it's happening again.
It happened again. So what would you do then, Caleb, to do a simulation this time?
You would see how long it takes to get forward.
Right. So you look at 8 numbers on the chart or on your random calculator generator, and you'd see how many times you get 4 of those 8 from the original 1 to 28. Very good. All right, so let's see. Elena,
How many
read
parties
number
plus were there
2.
total?
Pardon?
How many parties plus were there total?
How do you find the
How,
total?
how many were there?
On 95.
I mean, 5, okay.
28
Very,
of the
very
numbers
helpful
you're
with
picking.
99.
Yeah. Elena, read number 2. All right, see if you can, this is a little different. See if anyone can come up with a reasonable simulation. And this will be our last point for today on as far as classwork stuff. Yeah, Elena, read about this one.
Refer to the NASCAR and rugby series example. What is the
No, they didn't tell you what it was. Where is it? All right, sorry, Elena, I have to interrupt you as well. All right, it turns out, you ever have the old cereal box with the card in it? Well, this is NASCAR people. So the NASCAR people, I don't know their names, so I made them up. Jeff, Dale,
You should name our
Tony,
names.
Dan, and Jim. Don't they sound like NASCAR?
They do, actually.
Jeff, Dale, Tony, Dan, and Jim. So
Those are such NASCAR names.
I know. They might be real NASCAR names. It might be floating around in there somewhere, but I don't really
Like
know.
Tony and Dale both are.
All right. So anyway, this woman was into NASCAR, so she kept buying cereal boxes, and the NASCAR companies claimed, or the cereal company claimed, they were equally likely to be. Each card was equally likely to be in a box. So there was 1, 2, 3, 5 cards. So each one had a 1/5 chance of being in there. So it's not like they withheld a card. Do you ever remember being in a contest where you tried to get a whole set and you get the first,
Monopoly.
the first 10 right away, and then the 11th or 12th just never show up. So you know they have it rigged. Well, this is not rigged, or so they claim. So guess how many boxes the poor woman had to buy until she got all 5 names?
8.
12.
23.
You didn't let me finish. I was definitely gonna
Gotta
say
be
23.
quick.
I was going to say
23.
higher.
Because it's on
23.
point.
Don't
I
lower.
heard the 20 part.
23 days.
23 boxes, and she says, should I be surprised? And so we want a simulation for this. Any ideas? How we could set up a chance simulation?
Just do the calculator.
All right, so, but what would you do?
Do the calculator and see how long, instead of 1 to 5, and see how many.
All right, why don't you try it since you got it all out? So we're gonna do 1, 2, 3, 4, and 5, and we want to know how many boxes until we get all of them.
I'm
So
already at 2, 3, 4.
Plus.
2, 3, 4. Then what?
Oh, I threw.
Are you just getting repeats?
Pete and repeat. We're in a boat. Pete fell out. Who?